When you set up the block, you selected a soil description, and there were actually two ways of doing it. If you were using a calibrated neutron probe, you would have the neutron probe lead, and you would set the soil water holding capacity based on the neutron probe reading. If you're not using a neutron probe, you would have gone straight to the soil texture description and picked a water holding capacity from that. And regardless of which one of these you use, if you later have to tweak it, you would simply go back to the field capacity settings and tweak those numbers. So let's look at how we would edit the soil setup after we've done it initially. And this is the same menu that would come up when you were setting up a block for the first time. So if I click on this, it opens the sheet where I can see the soil description that I have made. There is a FCAP reading associated with that, and these are blank because I did not use the spore calculation to get to this. I simply went into this description right here, selected salty loam, and came up with the number. We could have done it differently. We could have clicked on the spore diagram, said we know that we have a salt loam, and it's quite a large range of soil description, but we could have come up with a value here. And when we close this, that would be the new set value. And now we're getting the associated calculation from the spore diagram. So again, in this diagram, two ways of doing it. Either we go in here, use salt loam for instance, and come up with a default value for that. And to make it easy for guys, we have that copy all the way down, which in an instance like this is not a good idea because we have just overwritten everything we had down. So either we're going to use the soil description to come up with a value, or we're going to use the spore diagram to come up with a value. If you have made any changes in this diagram, and this is really the controlling field right here, then we're going to save it and we're going to recalculate. Now note this little field down here which says the drainage rate. It is associated with the soil type of what would be the hydraulic conductance of the soil. And in practical terms, if this profile is above field capacity, how fast will we lose water at the bottom? And this is in inch per day. Now think practical, you could have sand which would normally drain really quick, but if that sand is sitting on an impervious clay layer, if the drainage has almost become zero. So the way the software works, it will look at the bottom of your root zone. So if we had a clay layer at the bottom of the root zone, it will default to a value that is realistic with the clay, meaning that anything above that would have to drain through the clay to get out of it. So if you've made any changes, remember to save.